Hey there, welcome to First Line to Last Mile with Kim. I'm Kim. I have over 30 years of experience developing software. The last 10 years I've been at early stage startups, and with the most recent one, Deepcast, I got a lot of experience working with generative AI as well. And it's summer, and my kid's on summer break, so I also thought this would be a great opportunity to build a math app with some code vibing. We're going to go through a couple of different scenarios working with prompts. In another episode, I'll show some more examples of iterating on top of, and probably also doing some troubleshooting when you're working with generative AI. I picked Visual Studio Code and Copilot because there's a lot of organizations that use Visual Studio Code and also GitHub, and so that's a very easy way to enable this tool. So with that, let's get started. We have a completely blank directory here, and I'm going to open up Copilot. For this exercise, we're going to use Claude Sonnet 4. You can also pick some other models, including the latest GPT, depending on the plan that you have with GitHub. But today I'm using Claude Sonnet 4 primarily for the reason that I also want to use the Remix framework. And when I try to direct GPT 4.1 to use it, it gets confused. Whereas Claude Sonnet has up-to-date working knowledge of building applications with Remix. For those of you who know Remix, you also know that most recently it was merged into React Router 7, but Claude Sonnet 4 is not quite up to date with that development, and Remix is still recent enough that it's not a big deal to use Remix instead of React Router 7. So let's get started with the prompt. First, I'm going to do a super high-level prompt, very brief, and we'll see what we get out of that. Create a math app for elementary school grades with a very friendly UI. Please use React and Remix. Okay, so that's running. It's going to take quite a while. It's going to scaffold the files from a template, and then it's going to generate the actual implementation on top of that. I will go off camera, speed this up when I edit the video, and then we're going to come back and review the changes after, because otherwise it's going to be many minutes in between me talking where we're just watching Copilot do its thing. Okay, Copilot is wrapping up. We're going to walk through what it gave us, starting with instructions. The prompt was very brief, right? We're just asking it to build a math app for elementary school grades with a friendly UI, built on top of React and Remix. That was it. And so what happened was, one of the first things was it generated much more detailed requirements for the app, and so in the absence of me providing guidance, it came up with a lot of additional requirements on its own. For example, it decided on operations addition, subtraction, multiplication, and division, and it came up with some additional technical requirements, reusable components, so all very reasonable, but also things that it decided on without additional input from me. Some more detailed requirements on styling, and then in terms of data management, it says it's storing user progress and scores, but I'm pretty sure it's not doing it server-side. However it does it, it must be client-side. And so let's take a brief look at the routes. And actually, let me keep these changes because this is all generated from scratch, so it's a little bit easier to look at. So index is the landing page in a standard Remix application. And under the route directory, the names of these, they become paths in the web application. And so I'm not going to go into too much detail about how that part of React Router and Remix works. You can go and look it up, and I'll put some links in the episode notes so you can dig further into that if you're new to Remix. But suffice to say, this is the landing page and specifying the operations that you can do. And then there's the UI code for actually doing that. And then it generated the page for each of the math operations, and at a glance it's using React state, the useState hook, and sometimes it ends up using local storage. I don't actually see that here. So I think in this case, it's all just your scan.react component state that is using here to store the progress. And then if we look at the other pages, they're very similarly generated in a very consistent fashion, which is good. And then if we were to actually keep working on top of this particular version of these files, then we will probably at some point consider things that we can refactor out into shared components. And so it's also interesting that it did come up with the requirement to have reusable components, and yet there are definitely big parts of the layout that at a glance looks like there's a lot of repetition among these files. But again, I don't think that's bad. In fact, I'm a big proponent of rule of three. When you're developing something new, just go and develop it. And only when it's the third time or the fifth time or the 10th time, depending on the size and the scope of it, then you can allow yourself to take a step back and consider what are the actual common things here. Because a common programming pitfall is definitely trying and matching upfront what are all the things that you would need in order to build a reusable component. And sometimes you get it right, but sometimes I find that the things you thought you needed didn't actually turn out to be necessary. And maybe the places where you put the shared code might actually need to be sliced and diced in a different way than you originally imagined before you actually understood what needed to be done to implement the code. Anyways, back to this code. Let's see what it actually looks like. Okay, so it definitely followed the spirit of making it friendly for elementary grade school children. It's big fonts, lots of colors, and some progress here. And let's see what happens when we do addition. We can choose between difficulty levels, so that's something it came up with on its own. Let's give a wrong answer. Okay, so it told me I didn't get it right, and then I can go to the next problem and let's get that one right. And so now we have 1 correct out of 2, 50% success rate, and now it's 2/3. And next problem, let's get that one right as well. Okay, and so on. Let's go back. So I think in a nutshell, we definitely got a lot of functionality out of this very brief prompt. I think the first point I want to talk about here is that once you see it, you probably begin to realize, oh, I actually have opinions about much more about how I want this thing to work. Again, this is a completely from scratch Greenfield situation. And because it is that, and because Copilot generated all of that code, there's not a lot of sunk cost hesitation to scrap this and start over. So if you want to experiment, then we can shoot off this exact same prompt and we're going to get something slightly different back. And so you can keep iterating that way until you find a starting point that you feel is good. But the other really important point I want to make is that for architectural things like, for example, persistence, I would very much like this to be persisted in a database so that we can come back even across different devices and track our progress. And I also want the ability to track the progress of multiple children in the app. Those are big design decisions. And now that Copilot and Claude Sonnet 4 has already made a lot of decisions about the architecture and the implementation of this app, which it generated from scratch, right? If you now come in, you try to guide it and refactor the app, you run into a couple of challenges. The first one is that now it has to go and refactor this existing code that, even though it came from Copilot, each one of those files, you run the risk that it's going to run into some challenges or difficulties doing it. In some cases, it's going to be fine depending on the change you're asking for. But every time it touches a file, there's always the opportunity that there's going to be a random small or large thing that it gets wrong. And then you have to further work with it to massage that. And that touches on the second thing, which is that there is now a technical debt, because you ask it to generate and it generated all of this stuff. And if you then come back and ask for things that are architecturally kind of fundamental, like persistence, that touches a bunch of pages. Now it has to go and touch all of those pages, and you have to wait for it to do that work, even if it does it correctly on the first shot, right? So if you are in a situation where you're starting from scratch, then you can keep doing that. And for prototyping or for ideation, that's great, right? You can see what you get and scrap it and shake the bag, see what comes out next time. And so that's exactly what we're going to do. We are going to scrap all of this, and then I'm gonna come in with more opinions about what I would like to build. And let me just make sure that we have removed everything. There. And there. Okay. Let's get rid of that window. Now, I want to give some instructions about persistence. I want to store progress in a database. I want multiple children to be able to use it. I also would like that the problems are grouped together in levels, because I feel that an endless series of math questions is going to feel draining to the kids. And if you have small levels that you have to complete, then I think you get a better sense of accomplishment and achievements, right? So let's give those directions to the prompt. Create a math app for elementary school grades with a very friendly UI. This part is the same. Now comes the new stuff. Each child picks their profile by clicking on an emoji avatar. Progress profiles and progress must be stored in a database. Math problems should be grouped in levels, with 5 problems for kindergarten, 10 problems for first grade, 15 problems for second grade, etc. The children must answer 80% correct to advance to the next level. Each level is successively more difficult. Please use React and Remix. Okay, so we filled much more requirements in the middle between the beginning and the end that is the same as the first prompt. Create a math app for elementary school grades with a very friendly UI. Each child picks their profile by clicking on an emoji avatar. Profiles and progress must be stored in a database. Math problems should be grouped in levels with 5 problems for kindergarten, 10 problems for first grade, 15 problems for second grade, etc. The children must answer 80% correct to advance to the next level. Each level is successively more difficult. Please use React and Remix. Clearly, we've expanded a lot more on behavior of the app, the features in it, and the infrastructure. And yet, there's still a lot of room for Copilot to come in with more detailed requirements and implementation decisions that he's going to make. Same as last time, I'm going to fire this off, and then we're going to come back when it's done generating all of the files. Okay, we're back. Copilot wrapped up creating the files for the second version of the math app. And as we can see, it generated more source files, and the app looks slightly different this time around, just because of the random element of running the same prompt multiple times. You're gonna get slightly different output, but for the most part, it still followed the same idea of big fonts, lots of colors, big buttons and that kind of stuff. So this time it decided on Prisma as the third-party library to do the database ORM operations. And it also included the seed file, and it went bottom up. It started with the schema, the model definitions that ultimately become tables in the database, but also have code wrapped around it so that it's easy to access and modify and create rows in the database through TypeScript definitions. So that came first, and then it generated the routes. This time the landing page lets you start creating a profile, or maybe it just shows you what you get with a profile. No, it starts out by having you pick the emoji. So let's pick an emoji. And then we run into an issue. Let's see what the problem is. So I'm guessing it probably wants to go to create profile, which has code for loading and persisting profile information. And then there's a dashboard, which is probably when you have created a profile, it's going to show this. And then finally, there's supposed to be the game page where you solve math problems in a level. But right now, the first issue we have is that we are on the landing page. And let me just check these windows. So one thing I've noticed that happens every time you run with this tech stack and Copilot, it ends up first defining a task for running the development server, and then it also starts the development server again manually, which means that you end up having two development servers running in parallel. It probably doesn't do any damage, but it can definitely be confusing. So now we only have one, and it's the one that's running on port 5174. And okay, so it loaded. So that's the other thing. When you do a lot of replacing a lot of files with Remix, then sometimes you have to reload for it to actually pick up the changes. So this time around, we did get to the create profile route, and it's then asking us for a name. Let's pick Jane, and it's asking us for a grade. Let's do first grade. And then I'm gonna click on start my math adventure. And now we are probably on the dashboard page, and it shows overall progress, so 0 out of 2 levels. And then we can start level and we can follow. I guess we have to find out what the difference is between this and this. It may be the same, but just different ways of navigating to it. And then we can switch profiles. So now on the landing page, it shows the profile that we already generated. Let's take a quick look at the database, and we're going to ask Copilot to launch Prisma Studio for us. Can you start Prisma Studio? Okay, here are all the tables that were created from the model that Copilot's generated, the model definitions. And we can see we do indeed have one user created, the one that we just created. So that's good. That means that persistence of that part is working. It generated a lot of math problems. And let me see. So these math problems are tied to levels, and the levels are associated with grades. So it looks like they're disconnected from children. So that's good, because one thing that I probably would have asked it later on would be to make sure that problems in each level are consistent and the same. So if you're doing kindergarten level 1 subtraction, then you should get the exact same numbers again, but it already does this time around. And so attempt probably has a link between the user ID and the problem ID, and indeed that is what we see here. So that's all great. It means that we got successfully generated code for creating profiles and generating the levels and problems using a seed file. But that also means that if we need to update the math problems, we can just go into the database and update the values. So that's all great. I did notice that it mentioned that it needed to fix navigation to the level page, but it doesn't look like it actually did it. So let's test if that actually works. So let's go back to Jane and let's say start level. It does work. Okay, so maybe it's passing through the user ID as a query param, which at least for now, that's fine. I think we'll probably come back in the next episode and work on changing that. But for now, one other pretty major feature that we got that we didn't ask for, but I think is actually fine, is that it decided to make these multiple choice instead of text input, which I think for kindergarten and first grade is appropriate. So in this case, let me say what's 10 plus 10? It's 20. Great job. Problem 101. Well, 1 of 10. What is 1 plus 1? Okay, let's say that's 5. And then it said not quite. The answer is 2. And then we go to next problem. And so on and so forth. So that all looks great. So we have answered 2 successful out of 3, and there are 10 problems total. And one of the requirements we gave was it had to be at least 80% to pass. So let's keep going. 6 plus 1 is 7. Next problem. 5 plus 5 is, let's say that's 5. No, that was wrong. 9 plus 1 is 10. Next problem, 9 plus 5 is 14. How far are we? We have 3 more to go. And we're at 71% accuracy. Okay, 75% accuracy. And 78. Are we gonna get there? Are we gonna get there? 16. Okay, so we completed the first level. And so I guess the next level is subtraction, and it's now indicated that we successfully completed the first level. Let's fail this one and see what happens. That is 0, no. That is 4, no. That is 1, no. That is 9, no. That is 10, no. How far are we? We're halfway there. Okay. And so again, we're trying to fail this level. And I guess you have to go all the way to the bitter end, even if there's no way that you can actually reach 80%. That's fine for now. Let's just roll with that. What happens if I do next problem? Oh. Okay. Yeah, okay. 9. Okay, 0% accuracy. And then it says try again. Okay, and then it just starts over. So that's all fine. Okay, so I think this is a good place to recap what we did, what we got, and then tee up the next episode. And we tried out a very super high level prompt to begin with, just asking for a math app for kids basically. And then in the absence of additional guidance, Copilot came up with a lot of additional requirements, which it captured in a file called Copilot instructions. It uses as context, so when you do subsequent prompts and you're working on this, it comes back to this file to get high-level directions of what was all of the detailed requirements that we agreed on for this thing. You can add additional stuff in the context yourself too, things that help give Copilot context for the work that is happening. One key point of how this all works is the LLM models. They've been trained on vast amounts of data, including lots of software projects, and it's very clear here that Claude has definitely seen a lot of math applications and child-friendly applications, so it's very easy for it to pattern match and compose from the material that it's been trained on. It can compose relatively confidently different versions of math apps for kids. So you get something, and there's definitely variation in what you get, but if you don't specify what you want, then it's going to pick something for you. And once you have it, if you then decide to change it, at some point you end up having to refactor those decisions that it did. And if that's just the landing page, for example, that's fine. That doesn't take much time to do. But if it's architectural stuff like, oh, wait a minute, I actually want to store stuff on the database, and it's already generated 5 different pages for you that do things that you would want to persist on the database, then Copilot has to go back and now modify those files, right? So if you're in a situation where you're starting from a blank slate, then you can iterate until you find a version that you feel is good enough or close enough to where you're trying to go. And then once you commit to a version, then at that point you have to iterate on the code that is already there. I do think it's a great tool to try out and just experiment and see what you get. And it's not uncommon that You have an idea of what you want to see, but once you see concrete examples, it's much easier to verbalize and get opinionated about, I like this, I don't like that kind of thing. So the second time around we ran this prompt, we gave it much more detailed instructions about how we wanted in persistence to work, and also the game mechanics of the math app. And it definitely delivered on that. And I think it also managed to get the code to a place where persistence actually works across all of these pages. That doesn't always happen. Sometimes you have to go in and do some debugging and some troubleshooting to help it get the code to a place where it works. But this time around it succeeded, and it looks like persistence is working. Let's actually double check that the second attempt, when the 2 levels that we did, they all completed. And here we see a complete record of all the answers that we did. Let's go back to attempt, to user progress, and we can see that we tried it twice. We completed the first level with 80%, and that's noted here. And then we failed the second attempt with 0 correct answers. So that all looks like the persistence is working as we intended. And so for the next episode, I want to come back and then iterate on how some of this game mechanics works. I would, for example, to have each level be a combination of math problems instead of all of them addition, all of them subtraction, and so on. The way that it generated the problems, it may just be a matter of tweaking the seed file that was generated. But we'll see, and then we'll come up with a couple of other things to iterate on the app with. And so with that, thank you so much for watching, and I hope to see you again in the next episode.